Okay, what I'm doing now is instead of just a lump resistor, I'm using a coil as the resistance. Right now I'm using 5.3 ohms of this, one of the secondaries of this bit transformer. So I'm just using this coil as a resistive load, except it's a coil, inductive load. And what I got for the input is 200 milliamps and 12 volts, so it's 2.4 watts input. And the coil's not getting hot or anything. I can feel it humming. Now I have a 30 UF cap here, 30 UF cap, that I have the 5.3 ohms of this coil across. So I have 5.3 ohms worth of coil across this 30 UF cap. The cap is being filled from the two secondaries of this bit transformer that I pulled all the florist wire back so it's not touching the coils. Just seeing what happens like that. So the two secondaries in series here into a 30 UF cap with a 5.3 ohm coil across it as a load, and I'm getting 7.7 volts. Measuring across the capacitor here. So that comes to 10.2 watts if you do 7.7 times 7.7, so 7.7 squared, and then you divide by the resistance 5.3, and that gives you 10 watts. Now with 2.4 in. Now let's change the resistance. I'm going to use the primary coil as the resistive load of a coil, and it's 8.8 ohms. So, whereas I just did the secondary, now I'm going to do the primary of this bit transformer as the load. So I'm just using the resistance of the coils of this as a load. I'm not like using it as a transformer. Okay, now look what I have. 15.2 volts. So if you square this, 15.2 times 15.2 divided by the resistance, 8.8 ohms. And here's the input, 2.6 and 11.8 volts. I'm going to use my, well anyways, I think this comes out to about 25 or 30 watts. 15 times 0.2 times 15.2 is big number, and then you divide by 8.8. You can do the math yourself. I don't want to turn my phone off and do it. So, but this is about if this is true, this works as a resistive load. It's like 10 times over unity. Now, what I'm thinking is if this was to be running a motor, it would be an inductive load on it, would it not? So maybe this is a better test than using these resistors. Maybe not. Okay, so there's another test of this. Sorry about the mess. Okay, I'm going to give you the numbers one more time. 11.9 volts in and 30 milliamps now. 300 milliamps, 11.9 volts. So that's like 3.6 watts. Across the capacitor is 15.3 volts now. Voltage, and also across the capacitor is 8.8 ohms worth of coil. So if you want to do the math. Okay, thanks for watching.